It is indeed possible to run two 2 horsepower 480 volts motors from a single starter. Let's discuss the sizing of current protection and overloads. Regarding current protection, each motor draws approximately 2.8 amps. This is calculated by dividing the horsepower by 0.746 kilowatts, then dividing by 1.73, resulting in approximately 2.76 amps. With two motors wired in parallel, the combined current draw is approximately 5.6 amps, which is 2.8 amps times 2. Therefore, the current protection device should be rated for a minimum of 5.6 amps. Now let's address overload protection. Overloads are designed to protect the motors from excessive current draw. For these two 2 horsepower motors, each with a rated full load current, or FLAW, of 2.8 amps, the overload setting should be 125% of the FLA for each motor. This results in an overload setting for each individual motor of 125% times 2.8 amps, which equals 3.5 amps. Since we're running the motors in parallel, the combined overload setting is 3.5 amps times 2, which is 7 amps. When it comes to starter selection, you should choose a starter rated for at least 480 volts and 7 amps. Some options include firstly, a solid-state starter with a rating of 480 volts and 7 amps, and secondly, a magnetic starter with a rating of 480 volts and 7 amps, equipped with overload relays rated for 3.5 amps. For wiring, connect the two motors in parallel and then connect the parallel motor connection to the starter output terminals. Always follow the starter manufacturer's instructions for proper wiring and installation. It is crucial to remember that motor overload protection is essential to prevent motor damage from overheating or overloading. Proper sizing and installation of current protection and overloads are critical for the safe and reliable operation of the motors. To further clarify, let's delve deeper into the specifics of selecting the appropriate components and wiring techniques. The current protection device, often a circuit breaker or fuses, needs to handle the inrush current of both motors starting simultaneously. Motor inrush current can be significantly higher than the full load current, typically 6 to 8 times the FLA. Therefore, the selected device must have an appropriate time delay characteristic to allow the motors to start without tripping unnecessarily. Consider using inverse time circuit breakers, which allow a short duration overload without interrupting the circuit, or time delay fuses specifically designed for motor protection. Moving on to overload protection, these devices are specifically designed to protect the motors from sustained overcurrent conditions that can cause overheating and damage to the motor windings. Overload relays are typically thermal or electronic and are selected based on the motor's FLA. As previously mentioned, setting the overload relays to 125% of the FLA provides a margin of safety while still allowing the motor to operate under normal load conditions. When choosing a starter, consider the motor's starting method. If the motors are started across the line, a full voltage starter is sufficient. However, if reduced voltage starting is required to limit inrush current, a reduced voltage starter, such as an auto-transformer starter or a part winding starter, may be necessary. Ensure the starter is rated for the appropriate voltage, current, and horsepower of the motors. The wiring connecting the motors to the starter must be sized correctly to handle the combined full load current of both motors, as well as the inrush current during starting. Refer to the National Electrical Code, NEC, Table 310.15b16 for ampacity ratings of conductors. The conductors should be rated for at least 125% of the combined motor FLA to account for continuous operation. Additionally, consider the ambient temperature and damping factors when selecting the appropriate conductor size. Branding is another critical aspect of motor installation. Ensure that the motor frames are properly grounded to prevent electrical shock hazards. Use a grounding conductor sized according to NEC Table 250.122. Connect the grounding conductor to a common ground point at the starter location. Control wiring is also necessary for the starter operation. This typically includes wiring for the start-stop push buttons, overload relay contacts, and other control devices. Use appropriate control wiring that is rated for the voltage and current requirements of the control circuit. Ensure that all wiring connections are properly terminated and tightened to prevent loose connections, which can cause overheating and electrical failures. Furthermore, consider the environmental conditions in which the motors and starter will be operating. If the motors are located in a dusty, wet, or corrosive environment, select enclosures and components that are rated for those conditions. Use weatherproof or explosion-proof enclosures as necessary to protect the equipment from environmental hazards. Regular maintenance is essential for ensuring the reliable operation of the motors and starter. This includes inspecting the wiring connections, cleaning the motor windings, lubricating the bearings, and testing the overload relays. Follow the manufacturer's recommendations for maintenance intervals and procedures. When troubleshooting motor problems, always follow safe electrical work practices. De-energize the circuit before working on any electrical components. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. If you are not qualified to work on electrical equipment, consult a qualified electrician. In addition to the above considerations, it is important to be aware of any local electrical codes and regulations that may apply to the installation of motors and starters. These codes may specify additional requirements for wiring, grounding, and protection. Consult with a local electrical inspector to ensure that the installation meets all applicable requirements. Also, consider the power factor of the motors. Power factor is a measure of how efficiently electrical power is used. Low power factor can result in increased energy consumption and voltage drop. If the motors have a low power factor, consider installing power factor correction capacitors to improve the power factor and reduce energy costs. The capacitor should be sized appropriately for the motor horsepower and voltage. Furthermore, harmonic distortion can be a concern in motor installations, particularly when using variable frequency drives, or VFDs. Harmonic distortion can cause overheating of electrical equipment and interference with other electronic devices. If harmonic distortion is a concern, consider installing harmonic filters to reduce the distortion levels. The filters should be sized appropriately for the motor load and the level of harmonic distortion present. When selecting a starter, consider the availability of spare parts and technical support. Choose a reputable manufacturer that offers readily available spare parts and provides technical support in case of problems. This will help minimize downtime and ensure that the motors can be quickly repaired if necessary. The installation should include a clear and legible wiring diagram that shows the connections between the motors, starter, and other control devices. This will make it easier to troubleshoot problems and perform maintenance. The wiring diagram should be kept in a safe and accessible location. When connecting the motors in parallel, ensure that the phase rotation is the same for both motors. Incorrect phase rotation can cause the motors to run in opposite directions, which can damage the motors and the equipment they are driving. Use a phase rotation meter to verify the phase rotation before connecting the motors. Furthermore, consider the use of motor protection relays. Motor protection relays provide advanced protection features such as overcurrent, undervoltage, phase loss, and ground fault protection. These relays can help protect the motors from a variety of electrical faults and prevent costly damage. The relays should be programmed with the appropriate settings for the motor horsepower, voltage, and current. Consider the use of a programmable logic controller, or PLC, to control the motor starter. A PLC can provide advanced control features such as automatic starting and stopping, sequencing, and monitoring. The PLC can also be used to interface with other control systems in the plant. When installing the starter, ensure that it is mounted in a location that is easily accessible for maintenance and troubleshooting. The starter should be mounted on a sturdy surface and protected from physical damage. Provide adequate ventilation around the starter to prevent overheating. In conclusion, running two 2-horsepower 480 volts motors from a single starter is feasible with careful consideration of current protection, overload protection, starter selection, wiring, and other factors. By following the guidelines outlined above and adhering to all applicable electrical codes and regulations, you can ensure the safe and reliable operation of the motors. Remember that proper sizing and installation are critical for preventing motor damage and ensuring long-term performance. Always consult with a qualified electrician if you have any questions or concerns about motor installation. Always prioritize safety and follow all applicable electrical codes and regulations. Motor control circuits often include auxiliary contacts for interlocking and remote indication. These contacts can be used to provide feedback to a control system or to prevent the starter from operating under certain conditions. Ensure that the auxiliary contacts are wired correctly and are functioning properly. Regularly inspect the motor windings for signs of insulation damage. Insulation damage can be caused by overheating, moisture, or chemical contamination. If insulation damage is detected, the motor should be repaired or replaced to prevent electrical failures. When replacing a motor, ensure that the replacement motor has the same horsepower, voltage, and frame size as the original motor. Using a motor with different specifications can cause problems with the starter and the driven equipment. Motor bearings should be lubricated regularly to prevent wear and tear. Follow the manufacturer's recommendations for lubrication intervals and procedures. Use the correct type of lubricant for the motor bearings. Variable frequency drives, or VFDs, can be used to control the speed of the motors. VFD can provide energy savings by reducing the motor speed when full speed is not required. When using a VFD, ensure that the motor is rated for VFD operation. Some motors are not designed to be used with VFD and can be damaged by the VFD switching frequency. Consider the use of soft starters. Soft starters provide a gradual increase in voltage during motor starting, which reduces inrush current and mechanical stress on the driven equipment. Soft starters are a good option for applications where reduced voltage starting is required. Surge protection devices, or SPDs, can be used to protect the motor and starter from voltage surges caused by lightning strikes or other electrical disturbances. SPD should be installed at the service entrance and at the motor starter location. Regularly inspect the motor cooling fan to ensure that it is functioning properly. A malfunctioning cooling fan can cause the motor to overheat and fail. Ensure that the motor is properly aligned with the driven equipment. Misalignment can cause excessive vibration and wear on the motor bearings and the driven equipment. Check the motor terminal box for signs of corrosion or damage. Corrosion can cause loose connections and electrical failures. Replace the terminal box if it is damaged. Ensure that the motor is protected from excessive vibration. Vibration can cause damage to the motor windings and bearings. Use vibration isolation mounts if necessary. Consider the use of a motor management system. A motor management system can provide comprehensive monitoring and protection for the motors, including overcurrent, undervoltage, phase loss, ground fault, and temperature monitoring. Regularly test the motor insulation resistance using a megometer. Low insulation resistance indicates insulation damage and the need for motor repair or replacement. Ensure that the motor is protected from moisture. Moisture can cause corrosion and insulation damage. Use a motor enclosure that is rated for the environment in which the motor is operating. If the motor is located in a hazardous location, such as a location with flammable gases or dust, use a motor that is rated for that hazardous location. Hazardous location motors are designed to prevent ignition of the flammable gases or dust. Regularly inspect the motor for signs of overheating. Overheating can be caused by overload, undervoltage, or a malfunctioning cooling fan. If overheating is detected, investigate the cause and take corrective action. Ensure that the motor is properly ventilated. Proper ventilation is essential for preventing overheating. Do not block the motor's ventilation openings. If the motor is located in an enclosed space, provide adequate ventilation to remove the heat generated by the motor. Consider the use of a motor efficiency program. A motor efficiency program can help you identify and replace inefficient motors with more efficient motors. This can save energy and reduce operating costs. Regularly clean the motor windings to remove dirt and debris. Dirt and debris can cause the motor to overheat and fail. Use a vacuum cleaner or compressed air to clean the motor windings. Do not use water or solvents, as these can damage the motor insulation. Ensure that the motor is properly grounded. Proper grounding is essential for preventing electrical shock hazards. Use a grounding conductor that is sized according to the NEC. Connect the grounding conductor to a common ground point at the service entrance. In summary, running 2 horsepower 480 volts motors from a single starter requires careful planning and execution. By following the guidelines outlined above and adhering to all applicable electrical codes and regulations, you can ensure the safe, reliable, and efficient operation of the motors. Remember that proper sizing, installation, maintenance, and troubleshooting are essential for preventing motor damage and ensuring long-term performance. Always consult with a qualified electrician if you have any questions or concerns about motor installation. Remember, safety is paramount when working with electrical equipment. Always energize circuits before performing maintenance or troubleshooting. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. If you are not qualified to work on electrical equipment, consult a qualified electrician.